Learning objectives for this lesson are: only one, sketch and analyze graphs of logarithmic functions. Okay, to start with, the lesson is going to be based on graphing log functions or logarithmic functions. So here on the right of my screen it says graph the function log of x of base 3. That's what we're mainly concerned with for this lesson. On the left of the screen it says graph the function 3 to the power of x, or 3 exponent x. This has already been done in previous lessons, but we're going to in this lesson I'm going to show you the link between these two graphs. Okay, on the left we have our x values for my graph of the function 3 to the power of x. You can see we have my domain, which is my x values, going from -4, -2, -1, 0, 1, and 2. From that, I have obtained my range values, or my y values, or my values for f of x. 0.04, 0.11, 0.33, 1, 3, and 9. Remember exactly how we got these values. To get these values, for example, the first one, which is my x value is -4, we simply got my function and it's 3 to the power of -4. That could simply just be put into your calculator, or if you wanted to go a little step further, it will be 1 over 3 to the power of 4, and that would then be equal to 1 over 81, which in turn will be equal to 0.01. Okay, so that's where that 0.01 came from. I'm not going to do all those values for every single one of them. So when we have our x values and when we have our y values, what I can now do is I can now then graph my function. I've done that here very quickly. I've taken a snippet from GeoGebra. So here's my different points on this curve. We have the point -4 and 0.01. Now notice it's very, very close to my y-axis. Let me just mark in to my x-axis. Let me just mark in my x-axis here. And obviously then we have our y-axis as well. And remember as well, my y-axis sometimes is also referred to f of x. Okay, so back to my laser. We have -4 and 0.01, -2 and 0.11, -1 and 0.33, 0 and 1, 1 and 3, and 2 and 9. Now notice I didn't go to the number 3 because the number 3 would have given me a function, a point right up the top up here, would have given me 3 and 27. So I didn't effectively have enough space to graph that in, because as you're aware, this is an exponential function and it rises very rapidly. So in a lot of cases we don't have space to fit those graphs in on the actual screen. Okay, now let's move across to my function log x of base 3. So what exactly is going to happen here? So to graph this function, you will notice that it's actually the opposite values. I've effectively flipped them around. So we can see my x value 0.01, 0.11, 0.33, 1, 3, and 9. And my y values now are -4, -2, -1, 0, 1, and 2. So I actually haven't done any maths there. All I have is I've changed the x values with the y values. And from that then I've graphed my function of log x of base 3. So you can see there's my points. Yes, it is a curve, all right, but it looks a little bit different to the curve of 3 to the power of x. So you can see I have 0.01 and -4, 0.11 and -2, 0.33 -1, 1 and 0, 3 and 1, and then we have the 9 and 2. So you'll notice then on my next slide, which I'm going to flip to now, there is a slight difference or similarity between the two of these. Okay, there they are. Top one, I have my function 3 to the power of x. Red line, I have my function log of x to the base 3. Now remember what I did on the previous slide to graph my function of log of x base 3. I changed my x values with my y values. So you'll notice here then there's a line which is moving directly up between these two curves. So you could say that my whole design in front of you here now is symmetrical, right? It is symmetrical because the function f of x equal to 3x is actually the inverse of my log x to the base 3. So I could now say that f of x inverse is equal to log x of 3. So in future then, when I want to graph a log function, all I need to have is the exponential function, and then I change my values. I change my x values with my y values. So to summarize that, they are the inverse of each other. And to get the inverse, we simply just interchange or swap the x values with the y values. Let's look at another example. Okay, actually before I go on to another example, I've just summarized that on the bottom of the slide. You can see it is f of x equal to (3 to the power of x), then f inverse x equals to log x base 3. Also, if f of x equals to log x base 3, then the inverse of it is 3 to the power of x. So they're the opposite of each other. Okay, on to my next slide now.
Now before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Okay, little task for me to do. A little bit more maths involved in this one now. So another example similar to what I did on the previous slide, but I'm going to explain this in a little bit more detail, and I'll be graphing it myself, similar to what you'll be doing if you were graphing it on a piece of paper. So graph the function log x to the base 2. Now we actually don't need to work out my x values and my y values for log of x base 2, because we know if f of x equals to log x base 2, then the inverse is equal to 2 to the power of x. So I'm only concerned for the moment with this function. This is going to then help us to get my values for log x of base 2. So I have my domain. X equals to -4, -2, 0, 2, 4, and 6. So my first value, if I want to work out my f of x or my y value, it's going to be 2 to the power of -4. This is going to be equal to 1 over 2 to the power of 4. Again, you can just go straight to your calculator to do this anyway. So effectively it's going to be 1 divided by 16. So 1 divided by 16 is going to give me 0.0625. I'm going to round it up to 0.063. So into my box then, in here it's going to be 0.063. That's my first value. Next one is going to be -2. So I'll just work through this one as well. So it's going to be 2 to the power of -2, which is the same as 1 over 2 to the power of 2, which is 1 over 4. And we know when that's written as a decimal, it's 0.25. Next one is going to be 2 to the power of 0. So we know any number to the power of 0 always gives me 1. That was a nice easy one. Next one is 2 to the power of 2. 4. I've skipped 3, I've gone on to number 4. 2 to the power of 4. should give me 16. And my last one then is going to be 2 to the power of 6. 2 to the power of 6 should give me 64. Now notice on my screen here, I'm probably not going to be able to fit that last one in, but we have it done out anyway. Okay, let's plot these values now. So I'm now over to my right, on the right hand side. I'm looking at my x-axis and my y-axis. So let me just fill in a few different values here. First of all, I have my x value as my horizontal and my y-axis as my vertical. Okay, to begin then, remember what we were asked to do at the start of the question. We were asked to graph log x to the base 2. But what I have done here is I have mapped out 2 to the power of x. So what I need to do is I need to change my x values with my y values because we know it's the inverse of it. So my points are going to be, I'll write them out in point format now. 0.063 is now my x value, and that's mapped in with -4. Okay, let's plot this point first of all. Where exactly is this point going to go? It's going to be 0.063, so 0.063 on my x value, and -4. So I'm taking this to be very, very close to my y-axis, and I'm just plotting it in like so. That's my first value. My second value is 0.25 and -2. So where is this value going to be located? Back across to my x and y axis. This point is going to be located at 0.25 and -2. So roughly there on my screen. Next one is the point 1 and 0. So that's going to be a nice easy one to plot. Remember, it was 0 and 1 and I've changed the values. So the point 1 and 0 is going to be located right on the x axis like so. Next one is the point 4 and the point 2. So for the point 4 and the point 2, this is going to be located exactly there. Now I'm actually not able to fit in any more values because it will be 16 and 4 and 64 and 6, but it actually doesn't matter because we have enough to be able to graph this properly. Okay, so to graph this function, and the line will continue on. Okay, now notice something in this. Obviously, I haven't continued it down. I'm going to just continue it on there. It's going to get closer and closer to the y-axis, but it's actually never ever going to touch the y-axis. That's something that's really important as well. Okay, so I'm going to label the function then. This is the function f of x equal to log x to the base 2. Okay, so that's a demonstration of how we would graph this. Now I haven't used GeoGebra or Desmos in that. A lot of you probably will, but that's just kind of the old-fashioned way, or how we would do it if we were doing it on a piece of paper, possibly in the maths classroom. Now notice some very important parts to this graph as well, which we also need to mention. The domain of this graph. Remember, domain is my x values. So what exactly does my domain look like here? Right, look at my x values. I said a minute ago that this graph never touches the y-axis. So we can effectively say that the domain goes from 0 all the way up to infinity. Right? Effectively, it's going to continue on forever in this direction. That's my domain. My range now. My range is my y values. This graph is going to go down forever, but it's also going to rise up forever as well. So we can say then that the range goes from minus infinity to positive infinity. Okay, intercepts. Next one is very important. So what do we mean by intercepts? Intercepts is where it crosses the x-axis and the y-axis. It's never going to cross the y-axis, so it's only going to have an intercept with the x-axis. And the intercept with the x-axis, as we can see, is located at the point 1 and 0, which was down there. Okay, next one, important word which we've come across in previous lessons is our asymptotes. So what exactly, or where exactly are our asymptotes going to be located here? There's only one of them. My asymptote is located at the y-axis, okay, because it doesn't touch the y-axis, it runs directly alongside it. There's my asymptotes. So they're very important terms on how we help analyze graphs. That's something that's really, really important when we look at our different graphs. Okay, on my next slide then, we're nearing the end of the video, but what I'm going to do here is do a brief little demonstration on various different types of logarithmic functions and what their graphs look like. You should then, in your own time, as a little activity, go on to GeoGebra and play around with the various different types of log functions, similar to what I'm going to do here. Okay, so to start us off, we can see I have log of x base 2 already graphed out. You would have seen this on the previous slide anyway. So what I'm going to do next is in the top left, I've a new log function with the I'm going to keep them all as a base 2. And what I'm putting in my brackets then, I'm going to put in x and plus various different constant numbers. So x plus 1, look what's happened, it's moved to the left. X plus 2, it's moved further. X plus 3, x plus 4, and so on. But notice how it doesn't cross that line. The plus 9 doesn't cross the minus 9 line. Okay, that's that one. I'm back up here. I'm now going to be typing in minus numbers, so minus 1, and look what's going to happen to my graph. Minus 2, minus 5, I've skipped a few, and then my last one then, I think it's gone on to minus 9. So it's shifted away to the right. Back up to the top left, I'm now going to multiply it by a number. When I multiply it by a number, it increases up. Multiplied it by 3, multiplied it by 8, and so on. Back to my left, I'm now going to add a constant to it, so this will just shift the graph up. It takes on the exact same shape, so 1 plus, 2 plus, 3 plus, 8 plus. There are just some examples of that. I'm going to subtract then from it, so minus 1 will obviously go down, minus 2, minus 4, and minus 5. And you can see I'm doing all this in the input bar on the top left of the screen all the time, all the way down to minus 9. Next operation I'm going to do is I'm going to come back into my brackets and I'm going to do negative, so it flips it around. Negative 2x goes up, negative 3x, negative 4x. Next part of this, which is quite important, I'm going to come down to my base value now, and I'm going to play around with this a little bit. I'm going to put a value between 0 and 1, and you'll see what happens to your graph. So I've just put in 0.2 this time. Now I put in 0.5. So 0.5, it flips the graph right around. What happens when I increase this now? So 0.8, 0.9, 0.99, so it's near to 1, it's not quite 1. 1 gives me a straight line. What happens if I increase it past 1? There's 1.1. Let's increase this again. Can we go higher than 1.1? I'm now going to 1.5. So if the number is greater than 1, it looks this like a graph. If it's 1, it's a straight line. If it's less than 1, it's the opposite way. Okay, that gives you a little insight into some of those various different graphs when you play around with it as well. So there's my 0.5 as well, just to demonstrate that again. So as I said, in your own time, do exactly what I've done there. Go onto your GeoGebra and trial and error, try out a few of these different graphs and see what they look like. And ask yourself then, why does this happen to the graph? Why does it take on a different shape as we play around with the various different numbers?